After studying this module, you shall be able to learn about the industrial sector in India and its growth pattern. Identify the key parameters to track industrial activities. Evaluate the performance of Indian industries based on the data. Analyze the patterns and structures of various indicators of industrial production. Every economy tries to follow the best possible path to growth and development. After independence, Prime Minister Jawaharlal Nehru wanted to put Indian economy on a fast and inclusive growth trajectory. Primarily, India has been an agrarian economy. It was imperative to develop the industrial sector to put India on the road of self-sufficiency. Our earlier 5-year plans focused on industrial growth as a primary objective. The Mahalanobis model for growth was adopted and India started producing various industrial goods. The capital goods industries and the mining sector were at a nascent stage at that time. In addition, India was incurring huge import cost, and after the partition, food and basic products were scarce. The first 5-year plan focused on agricultural development to ensure food availability. And in the second 5-year plan, the government took it upon itself to set up factories in India for developing basic and heavy industries. After that, India saw various economic slowdowns and political events that led to deregulation, privatization and globalization of the Indian industrial sector. Post-1991 policy of liberalization, privatization and globalization, service industries grew in India and put India on the world map. IT-enabled services, that is ITES services, have been major contributors to the growth of Indian GDP during the past 15 years. In order to track the growth of various goods and service industries, a set of parameters can be observed over these years. Index of Industrial Production, that is IIP, Annual Survey of Industries, and Input-Output Tables, that is IO tables, are the main parameters or data sources which are used extensively in India to track the growth of various industrial sectors. IIP is an abstract and an absolute index that tracks the growth in various manufacturing sectors, mining and electricity industry over a short period with reference to a base period. This index is one of the most important economic indicators and is used extensively for policy planning. ASI is an annual tabulation exercise which covers all the registered factories at the pan-India level and collects data regarding labor and employees' wages, working hours and other related factors. The aim of this exercise is to review the structure and composition of industrial sectors and make room for required policy changes. Another important tool is the Input-Output Table. The IO table is a mathematical relationship between the industries in terms of use of intermediate and final goods. It is a very well advanced and widely used technique in industrial economics to derive the required economic vectors. Now let us discuss about index of industrial production. First, we can discuss about the composition and calculation of IIP. One of the key economic indicators in India is Index of Industrial Production, popularly known as IIP. This indicator gives details on the growth trajectory of various industrial sectors like mining, electricity and the manufacturing concerns. In gross terms, IIP charts out a basket of industrial products in terms of volume over a defined short period with reference to a base period. The Central Statistical Organization or CSO in India is the responsible authority to collect and publish this data. This index is tracked monthly and published generally after 6 weeks of the end of reference month. Some of the key terms related to IIP are: number 1, the index. An index is a composite representation in the form of an absolute number free of units of measurement with reference to a chosen point called base period. Then industrial production. All industrial activities which are classified under International Standard Industrial Classification, that is ISIC, forms part of industrial production. National Industrial Classification, that is NIC, is the basis for classification of all economic activities within the boundary of India. Then there is item basket, a representative collection of items selected by understanding their relative importance in contribution to economic growth for computation of the index. Almost 80% of the contribution in national product is from the selected basket. Composition of the basket is decided based on the availability of the data from various sources. Then there are weights. With a view to reflect the true performance of various industries in calculating IIP, weights are assigned to various components according to their importance. The current criteria for assigning weights is gross value added, or GVA, from that industrial activity. In the past, net value added by the manufacturer, and proportion to the total output have been used. Then base period. IIP is a ratio of production in the current period to the reference period. This reference period is called the base period. Selection of the base period is done considering normality, availability of all relevant data, proximity to the comparison period, and the synchronization with other macroeconomic indicators. IIP is an easy index to compute once this data is available. Generally, it is computed using Lespier's fixed base formula as the weighted average of production of all the industrial activities. That is, I is equal to summation Wi Ri divided by summation Wi, where I is the index, Ri is the production of the ith item for the month in question, and the Wi is the weight allotted to it. An industry can be divided based on the use category. So, an IIP is also calculated based on use classification, that is basic goods, capital goods, intermediate goods, consumer durables, and consumer non-durables. An important thing to note here is the use of price deflators while offsetting the effect of volume to value conversion. IIP is calculated in volume terms but represented as value index. Therefore, it is first deflated by the appropriate wholesale price index, that is WPI, of the concerned categories, released by the Office of the Economic Advisor, Ministry of Commerce and Industry. Now we can discuss about the current situation and base year revisions. Industrial production in India went up a better than expected 6.4% year on year in August of 2015, following a downwardly revised 4.1% gain in July and the highest since October of 2012. The manufacturing sector jumped 6.9%, electricity grew 5.6%, and mining output rose 3.8%. Considering April to August, industrial production increased 4.1%. Industrial production in India averaged 6.50% from 1994 until 2015, reaching an all-time high of 20% in November of 2006 and a record low of minus 7.20% in February of 2009. Looking at the trend line in figure 1, we can see a downward trend in the IIP. In the context of calculating IIP, classifications of activity or the industry and products are required to sort statistical information about economic units and their input-output data. India follows the National Industrial Classification for classifying economic activities, and this is also used in the compilation of the IIP. The NIC is adjusted to suit the Indian dynamics and follows the principles and procedures laid down in the United Nations International Standard Industrial Classification. Revision in NIC is done from time to time in line with ISIC to keep pace with the changes in the structure and organization of industries, besides accommodating for emerging economic activities. Since this indicator projects the growth rate of the economy, it is important to keep the base year as real as possible due to structural changes in industries. The recent revision of the IIP released by CSO with 2004-5 as the base year comprises 682 items and includes technologically advanced goods such as cell phones and iPods, and thus paints a better picture of the economy. The previous base year, that is 93-94 list, contained a collection of outdated items such as typewriters and the tape recorders. During 68 years of being independent, the base year has been changed more than 6 times. As India grew, various industries came into existence, resulting in the expansion of the basket. Now let us discuss about the data sources. IIP compiles data from 16 source agencies, viz. Department of Industrial Policy and Promotion, that is DIPP, Indian Bureau of Mines, Directorate of Vanaspati, Vegetable Oils and Fats, Central Electricity Authority, Joint Plant Committee, Office of the Textile Commissioner, Department of Chemicals and Petrochemicals, Office of Salt Commissioner and Coffee Board, Directorate of Sugar, Department of Fertilizers, Tea Board, Office of Jute Commissioner, Office of Coal Controller, Railway Board, Ministry of Petroleum and Natural Gas. Then there are other industrial growth indicators. The first one is that by Annual Survey of Industries. We can discuss first origin and scope of this Annual Survey of Industries. Annual Survey of Industries, or ASI, is one of the important sources of industrial statistics in India apart from this IIP and IO tables. This survey not only tracks the growth rate or flow of products and services, but realistically assesses the changes in composition and structure of organized manufacturing sector. The survey is conducted annually under the statutory provision of Collection of Statistics Act 2008 and the rules framed thereunder in 2011, except in state of Jammu and Kashmir, where it is conducted under the State Collection of Statistics Act 1961 and the rules framed thereunder in 1964. Before ASI was started in 1969, Sample Survey of Manufacturing Industries, that is SSMI, and Census of Manufacturing Industries, that is CMI, was conducted, which was later replaced by ASI. One of the key phrases to note here is the organized sector. ASI is conducted primarily in the manufacturing concerns which can be assessed under organized sector in India. Thus, all factories in India registered under section 2M1 and 2M2 of the Factories Act 1948 are covered under ASI. Servicing units like repairing of motor vehicles, cold storage, water supply and other consumer durables like watches etc. are also enumerated in this exercise. Defense establishments, oil storage and distribution depots, restaurants, hotels, cafe and computer services and the technical training institutes etc. are excluded from the purview of the survey. A factory in the case of manufacturing industries, a workshop in case of repair services, an undertaking or a licensee in case of electricity, gas and water supply undertakings and an establishment in case of BD and cigar industries is the primary unit of enumeration. Then there is ASI sample design and sample allocation. During 2012-13, a new sampling design was adopted according to which there were two samples, central sample and the state sample. Central sample further consists of two schemes, the census and sample. As the name suggests, under census all units are surveyed. In the census scheme, industrial units belonging to less developed union territories or states, Manipur, Meghalaya, Nagaland, Sikkim, Tripura, Andaman and Nicobar Islands are included. But for all other places, units having 100 or more employees and registered under joint returns are included. Then the sectors that are considered are BD, manufacturing and electricity, that is state, district, sector and 4-digit NIC 2008 classification. All the other units become part of sample scheme. The stratum thus formed is arranged in descending order of number of employees. To draw a sample, circular systematic sampling technique is used. An even number of units are selected and distributed in 4 subsamples. It may be noted that each of 4 subsamples from a particular stratum may not have equal number of units. Out of these 4 subsamples, NSSO gets 2 subsamples and state UT gets remaining 2 samples to collect the data. The complete census units along with the units belonging to the NSSO FOD subsample are considered as the central sample. The entire census unit and units belonging to state or UTs subsamples are treated as the state sample. Hence, state or UT uses NSSO census units along with their subsamples to derive the district level estimates for their respective UT or states. An accounting year is the reference period to conduct the ASI. The ASI has 2 schedules that are processed and presented by 2 different authorities. CSO, the IS wing, Kolkata, collects data on assets and liabilities, labor cost and employment, expenses, receipts, inputs, products and byproducts, etc. Part 2 is processed by the Labour Bureau. It collects data on different aspects of labour statistics, namely working days, absenteeism, man days worked, man hours worked, labour turnover and the social security benefits. The dissemination of ASI information is done on request through the Computer Center, New Delhi, which works as a data warehouse of the Ministry of Statistics and PI. Pricing policy is set by the Ministry of Statistics and PI. Now we can discuss about the concepts and definitions of items collected through the ASI schedule. The first one is related with the reference year. Reference year is an accounting year or fiscal year from April to March. Then the second one is for factory. Factory is one that is registered under section 2M1 and 2M2 of the Factories Act 1948. The sections 2M1 and 2M2 refer to any premises including the precincts thereof whereupon 10 or more workers are working or were working on any day of the preceding 12 months and in any part of which a manufacturing process is being carried on with the aid of power or is ordinarily so carried on, or whereon 20 or more workers are working or were working on any day of the preceding 12 months and in any part of which a manufacturing process is being carried on without the aid of power or is ordinarily so carried on. The fixed capital. Fixed capital represents the depreciated value of fixed assets owned by the factory as on the closing day of the accounting year. Fixed assets are those that have a normal productive life of more than 1 year, like land or building. Depreciation. Depreciation is consumption of fixed capital due to wear and tear and obsolescence during the accounting year and is taken as provided by the factory owner or is estimated on basis of the cost of installation and working life of the fixed assets. Some other definitions like physical working capital, productive capital, gross value of plant and machinery, wages, salaries, workmen, employees, gross emoluments, total input, total output, net value added. For this you can know in the next section. Now we can discuss about input-output tables. In an economy, various industries are linked to one another. The output of an industry can be used as an input to another industry, known as an intermediate production sector. This relationship between industries is an important parameter to understand in order to track the growth of the economy as a whole. One way is to make IO tables. Input-output tables are industry by industry or product by product matrices representing use and supply into a table with identical classification of industries or products. It is essentially a quantitative technique widely used in economics which was developed by Leontief. This model determines the physical quantities to be produced in each industry, which further is used to help in formulation of a consistent resource allocation plan. Indian IO tables. In India, compilation of IO tables was started in early 1950s. India follows principles from System of National Accounts, that is SNA, provided by United Nations, consistent with international format. One of the unique features of India's IO table is the use of fiscal year, that is April to March, as a reference period, unlike most of the other nations which use the calendar year, that is January to December. An important discussion here is how an economy selects among various intermediate sectors that are to be put in an IO matrix. For India, which has gone through various structural changes since independence, it is a difficult task. The latest format of the IO table 2003-04 has 130 intermediate industries from 115 in 1983-84. There are many challenges that are faced by an economy while making IO tables. Availability of data in required form, selection and classification of intermediate sectors, deciding on the flow in intermediate sectors are few to name. Basic concept and the derivation. One must understand the basic premise for an input-output table. Let us suppose we have an economy with n sectors where every sector produces xi units of identical goods and the jth sector must consume aij units from sector I to produce a single unit. There are two types of demand in an economy: intermediate demand, that is a sector sells its output to another sector, and the final demand DI, that is the goods which are sold to final consumers in the ith sector. Now this relationship can be expressed as Xi is equal to AI1 X1 plus AI2 X2 so on plus AIN Xn plus DI, representing total output in an economy with the single product equals intermediate product plus final output. Now let A be the coefficient matrix and X be the vector of total output and D be the vector of final demand. The production in an economy then becomes X is equal to AX plus D or I minus A into X is equal to D. Assuming that the matrix I minus A is invertible, we can solve this linear system of equations and can have a unique solution. If D is given for a reference period, we can find the required output. Following the Hawkins-Simon condition principle of minors of the matrix, I minus A are all positive values and X should have a non-negative value. Now let us look at the structure of an input-output table. The value of an inter-industry transaction in an IO table is given at factor cost in the form of commodity X industry matrix. Columns in this matrix represent the industries and the rows are groups of commodities, which are the primary products of the corresponding industries. Each row shows in the relevant columns the deliveries of final output of the commodities of various industries for intermediate and final use. The columns are read as the commodity inputs of raw material and services, which are used to produce outputs of particular industries. Net indirect taxes, that is NIT, or indirect taxes minus subsidies on inputs and income from use of labor and capital are shown at the bottom of the columns, that is gross value added. A simplified framework of input-output table is presented in table 2. Here, Y denotes the column vector of Yj and Yj denotes the value of primary inputs, that is factor incomes in the jth industry. The superscript prime is used to denote the transpose. IO reports in India consist of 7 such matrices. Table 3 presents a bird eye view of input-output accounts. Table 3, IO report matrices. This table shows matrix 1, matrix 2, matrix 3, matrix 4, matrix 5, matrix 6 and matrix 7. Now we can also look at the mathematical relationship between input and output. The input relations are Qj is equal to summation Xjk plus Fj. The output relations can be represented by Qj is equal to summation Mij for all k's and Gi is equal to summation Mij for all i's and j's, where Qj is the total output for jth commodity group. Gi is total output of all products and byproducts of the ith industry group. Fj is final demand of the jth commodity. Xjk is output of jth commodity used as input in the kth sector, that is the industry group. Mij is output of jth commodity produced by the ith industry group. Jth commodity group is represented by various commodities that are produced in an ith industry. So there can be I1, I2 industries and every industry will have different commodity groups like J1, J2, so on and Jn. The above symbols without subscript refer to the corresponding vectors. The technology assumptions. An input-output matrix is derived based on some assumptions which form the basis for obtaining homogeneous IO tables. In input-output analysis, there are two main assumptions, that is the industrial technology assumption and product technology or commodity assumption. The product technology assumption says that a product is made from same inputs irrespective of the industry it comes from. On the other hand, industry technology assumption undertakes that both primary and secondary commodities produced by industries have the same input structure irrespective of the commodity. This implies that all secondary products are treated as byproducts using the technology same as of the principal product of this industry. Indian IO report talks about mixed assumptions while making these tables. For mixed assumption, the output matrix can be divided into two parts such as W is equal to W1 plus W2, where W2 is a matrix of those byproducts which are to be transferred on the assumption of industry technology, and the elements of W1 are output which it seems reasonable to treat on the assumption of commodity technology. The formation of W1 plus W2 involves splitting individual elements of W, since these elements may contain a mixture of products, not all of which are to be treated in the same way. Now let us summarize what we have learnt from this module. Industrial activities in India started to pick up pace during second 5-year plan and then kept on increasing its coverage. Base year revision have been done more than 7 times in order to incorporate the effect if structural changes in the economic output. IIP is one of the most popular and frequently used industrial parameter judging the growth of activities with reference to a base period. Current IIP covers 682 items from mining, manufacturing and electricity industries. Other than IIP, annual survey of industries and input-output tables are important indicators of industrial sector health in India. ASI is an annual survey conducted every financial year to collect information about the structure and composition of organized industrial sectors in India. Financial statistics and labor-related statistics are collected by CSO and Labour Bureau. A new sampling design to collect data had been adopted in 2012-13, where there are two samples, central sample and the state sample. Central sample further consists of census and sample. Sample is drawn using circular systematic sampling. Input-output tables essentially give structure of intermediate production of various commodities in different industries. A mathematical relationship between inputs and outputs is derived within a commodity group and in an industry. Two main assumptions of drawing an input-output relationship is product technology and industrial technology. A lot of products assume to follow mixed assumption and thus treated accordingly.